Okay, so these rational inequalities really require a little bit of care and delicacy because you have all these little things to consider. You have to find out where things are 0, mark down where denominators are 0. You have to mark as an undefined place, make this sign chart, and read off the answer. So it's a little bit involved, and I thought I wanted to show you a slightly more exotic, a little bit harder kind of problem just to put all these ideas together. So like I said, this is a little bit tricky, but let's work through it together and see that it's nothing more than it's the same idea with a little bit of care. Okay? I want to find out all the points, all the values x, so that x squared plus x minus 6, when divided by x minus 4, in fact, is going to be greater than or equal to 0. Now here I'm mixing all the medium together. Do you see it? I've got a quadratic in here, and I've got a division thing going. I've got all this stuff happening at once, and you're going to see the process isn't going to be any different than it was before. It's just a little bit more involved. Step 1, make sure I've got 0 on one side and everything else on the other. I've got that. Step 2, make sure everything is just one fraction if it's just the fraction stuff. Well, I have one fraction. Step 3, if I see quadratics, can I factor? Well, let's hope I can. Otherwise, not going to be happy. So let's try to factor the top of that thing. I'll put an x and an x. That makes a lot of sense. This tells me I'm going to have opposite signs. Since these are both the same, I can write them any way I want. I need two numbers whose product is 6, but whose difference is going to be plus 1. That looks like 3 times 2 is going to work well. Where should I put the 3? Should I put the 3 by the negative? No, that would produce a negative x when I subtract off the plus 2. So I'll put the 2 here and the 3 here. 3x minus 2x is 1x. This times that is minus 6. Looks great. Don't forget the denominator. You might be so excited to factor that correctly, you might forget about the denominator. That's a great mistake to make. Always make sure you have everything written down there just like it was. OK, so same exact inequality, but now in a factored form. And now I can sort of see all the factors. There's this is a factor, this is a factor. And actually, you know, the way I think about it, I consider that a factor too, even though it's division. So I'm going to create one big sign chart. This is going to be a big one. This is like the mother of all sign charts. And I'm going to mark down where every single factor vanishes. OK, so let's see. Where does this thing equal 0? Well, wherever the top is 0. So wherever this equals 0, or wherever this equals 0. So when does x plus 3 equal 0? Well, that equals 0 when x equals negative 3. So I want to mark down negative 3. So I'll mark it way over here, negative 3. So there's a point that makes this whole thing equal to 0. So I'll mark that as a 0 here. And if you want, you could actually maybe want to mark this as like a little wall. You might want to put a little wall here, like a firewall. Oh, see, it's like a computer thing, right? Computer firewall. You want, I don't know what it does, but a firewall, it prevents forest fires. Do you know that only you can prevent forest fires? That's true. OK, so you can put this thing here, little firewall there. I make that green sort of for the ecological people. OK, so you got that. Now, when is this thing going to be 0? Well, that's 0. X minus 2 is 0 when actually x equals 2. So I'll put 2 way over here. Again, you can put in all the points if you want, but I'm not going to. There's 2. And again, that thing will be 0 there, so I put a 0 there. And it's a firewall. It's a firewall. So I'll put this thing there. But remember, I also want to mark down where the denominator of a fraction is 0, because those are the places where I know this thing is undefined. So where is the bottom equal to 0? Well, x minus 4 equals 0 when x equals 4. So actually, I'm going to put one more point here. It's sort of a scary point because it's undefined there. So I don't put 0, I put undefined because you can't touch that. Don't touch that point. You cannot touch that point because if you touch that point with an x, this thing is undefined. So you have to avoid that point at all times. Well, now you'll notice I actually cut the region up, cut this line up not into 3 regions, but 1, 2, 3, 4 regions. And so whatever's happening here, it's going to happen constantly throughout this region. The same thing here, here, and here. So I've got to go through each of these regions, pick a sample representative point, see what the sign of this is going to give, and then report the sign for that region. Okay? So same exact process, but notice it's a little bit more complex, but not any harder. OK, so I want to pick a point way off here to the right of 4. You could pick any number as long as it's bigger than 4. To really try to drive this home, I'm going to pick 1,000,000. So that sounds like a big number. And it is. But all I care about is the sign of this. And watch how I argue. I'm going to now plug in 1,000,000 wherever I see an x. If I put 1,000,000 in here, 1,000,000 plus 3, that's positive. If I put 1,000,000 in here, 1,000,000 minus 2, that's still positive. A positive times a positive, that's still positive. So I've got a positive on the top. If I take 1,000,000 and subtract 4, that's positive. So I see positive divided by a positive. Well, that's positive. You see how the fact that it was 1,000,000 really didn't make much of a difference at all? So that whole region is a positive region. Am I going to include that? Absolutely, because I'm looking for where this thing is positive or 0. So I'm going to include that. That's a happy answer. OK, what about over here? I need something between 2 and 4. How about I pick 3? So I'm going to pick 3 and plug it in. Let's see what happens. And all I care about is the sign. Now, if you want to, you can actually compute the numbers. But I don't do that. 3 plus 3, well, that's positive. 3 minus 2, that's positive. So I see a positive times a positive. That's positive on the top. If I put a 3 in here, 3 minus 4, well, that's actually negative. Negative 1. So I actually have a positive divided by a negative. That actually is a net gain of a negative. So in fact, this region here is a negative region. By the way, you might be saying, gee, boy, we're just wasting a lot of web time here. It's clear that whatever it does here, it's going to be this, opposite, opposite, and so keep switching back and forth. Do you know what? That's a great guess. And a lot of times that's true. But you know what? There are times where it's not. So you really have to check it, because this could be positive, negative, negative, positive, or something like that. So just because you switch doesn't mean that, in fact, these things are going to flip-flop. So it's a little word of warning. Don't think you can sort of jump ahead. You really want to take it carefully. OK, now I need something between negative 3 and 2. How about 0? So let's plug in 0. Here I see 3, that's positive. Here I see negative 2. So that's negative. So positive times a negative is a negative on top. And if I plug in 0 on the bottom, I see minus 4. So I see a negative divided by a negative. Negative divided by negative is positive. So in fact, here, it does switch back to positive. So I see a positive here. And then what happens out here? Well, now we can pick anything we want. Let's pick, like, negative a billion. How about that? Negative a billion. Let's do negative a trillion, just to really drive this home. Negative a trillion. Negative a trillion plus 3, negative. Negative a trillion minus 2, very negative. So I've got negative times a negative. That's a positive. Then if I take a negative a trillion and subtract 4, I get something else that's negative. So now I have a positive divided by a negative. That's negative. So in fact, I see negative regions all here. OK, so now I've created my sign chart here. I can read off my answer. I'm looking for where this thing is greater than or equal to 0. So where is it positive? Well, it's positive in this land, but it's also positive in this land. Right? Am I allowed to equal 0? The answer is yes, I am, because I see that little equal sign is there. So in fact, wherever I see a 0, I'm allowed to capture that. And so I capture that with these brackets. So those brackets mean I'm allowed to equal 0. And I should put the bracket here too, right? Because it's 0 there too. No, we don't, because that makes this undefined. Remember, you promised me you will never touch that point. You will never touch 4. So in fact, I put an open parentheses like that. But everything else is OK. So that's the graphical answer, graphical representation. Or you could write it in the interval notation by just sort of copying down what you see. So from minus 3 to 2 in brackets, because I'm allowed to include those endpoints. And then we have from 4 out to infinity, not including 4. And of course, we never include infinity. And then how do we bring them together? Well, it's one or the other. Since it's an or, we're taking a union. So you could write it like this with a union sign there. So you can see, even with a very complicated inequality like this, if you just take your time, make sure you have a 0, factor quadratics, make sure you have one fraction, mark the zeros of the top, carefully mark the zeros of the bottom as undefined, and then go through each little segment, see what the sign is, you can read off your answer. Easy as pie. You know what? Speaking of pie, it's time for me to go to lunch. So I'll see you soon.